First, the vocabulary. The quadratic model is a model based on quadratic function in the form ax squared plus bx plus c. Quadratic regression is an equation for the best fitting parabola through a set of points. Let's review what the graphs look like. So the graph looks like a parabola or a U shape. The point where it touches the x-axis, these are called x-intercepts. Or roots. Another word you might see as zeros. This is your vertex, the lowest point or the highest point. And in this case, since it's the lowest point, it's also considered a minimum. And this right here where it touches the y-axis is y-intercept. Keep in mind for an the y values are 0. For a y-intercept, the x values is 0. Similarly, for this graph, we have our two x-intercepts. We have our y-intercepts. We have our maximum or vertex, because this one's upside down. And that was off the mirror feature our parabola. Example 1. Consider a function f with the equation f of x equals 2x squared minus 3x minus 2. Find the x and y intercepts of its graph. So whether the parabola has a maximum or minimum and find its coordinates. So first we're going to press. So remember when we use our snowflake, we have our A term, which we'll do in gold, so that'll be 2 and 2. Our B term, which we'll do in red, that's -3 in this case. And then we have our C term, we'll handle that in this lava. So the top is going to be 2 times negative and the final answer for the top would give me -4. So what we're looking for is two numbers that we multiply to get -4, but we add them to get -3. So our multiples of 4 are 1 and 4, 2 and 2. So if we're thinking about things that multiply to make a negative number, one has to be positive, one has to be negative. So we can think about this in terms of subtraction. 4 minus 1 gives me 3, so that will be the numbers we're looking for. So let's write those in Galaxy. So we have a +4 and a 1. Now to determine which one's positive, which one's negative. In order to get -3, the 4 would have to be negative because -4 plus +1 will give me a -3. Now to write this in factor form. So 2 over 4, that would reduce to 1 over negative 2, because 2 goes into 2. 2 divided 2 is 1, and negative 4 divided 2 will give me negative 2. So we'd end up with 2x, x minus 2. Well, and then we have 2 over 1. We can't do anything with that. So our other factorization will be 2x minus 1. And we're done factoring. So to get our zeros, all we can do is set each one equal to 0. So say x minus 2 equals 0, and 2x minus 1 equals 0. So this one's easier, so I'll just add 2 to both sides. We'll get x equals 2. This one just add 1 to both sides. We'll have 2x equals 1. We'll divide both sides by 2. And x equals 1 half. So we have our zeros as positive 2 and 1 half. So let's plot this. So this should be a negative 1 half. The negative 1 half will be about here, and positive 2 will be about, let's count by, to make our life more simple, we don't have to count by single digits. So each of these will count as, this one as 1. So let's label this 1, 2, 3, 4, 5, and so on. In the other direction, negative 1, negative 2, negative 3, negative 4, and negative 5. So 1 half would be right here, 2 would be right here. As part of our graph, we just need our y-intercept. So that's when x equals 0. So you get the y-intercept, plug in 0. So that will give me 0 minus 2, and 2 parentheses 0 minus 1. 0 minus 2 would be negative 2 times negative 1, because 2 times 0 is 1. So that's going to give me positive 2. 1, 2. We'll continue using that as, oops, sorry, this should be a positive 1. So this would be negative 2. 1, 2. Okay, so our graph's going to look something like this. The only thing you have to figure out is what our x is. Let's continue on to the next page to get my vertex. So vertex. I'll be using the formula negative b divided by 2a. If we look at our original equation, our b was negative 3. So that would be negative 3 all over 2 times 2. Because our a was 2. So the opposite of negative 3 would be positive 3 over 4. So now we plug that into our equation to get our y-coordinate. We have 2, 3, 4 squared minus 3, parentheses 3 fourths, minus 2. So it's going to be approximately here. And we're going to do our exact value. So 2 parentheses 0.75 squared minus 3 parentheses 0.75 minus 2. We're going to get negative 3.125. So it will be approximately 1, 2, 3, right about there. So this is our parabola for our equation, and the vertex is at the point 0.75, comma, negative 3.125. We found our vertex, we found our x and y intercept, and we have completed this problem. You could also solve this using just by typing the equation into a graphing calculator, and you should, or GeoGebra or Desmos, to find the x-intercept, the y-intercept, and the vertex. I hope this helps you understanding graphing a parabola. Example 2. A ball is thrown upward from a height of 15 meters with an initial velocity of 20 meters per second. Find the relation between h and time t after the ball is released. We'll use the Desmos calculator to answer parts B and C in the graph. So first thing we need to know is our height equation. So let's start writing it out. It starts as h equals 1/2 gt squared plus v0 t plus h0. G is your acceleration with respect to, that's what W is for, gravity. It's always 9.8 meters per second squared. V0, or your initial velocity, is given in the problem, and that's just 20. Let's write that down as initial velocity first. So this is your initial velocity. And it's given the problem as 20 meters per second. And then h0 is your initial height. And this is given in the problem as 15 meters. So our equation is going to be h equals 1/2 times 9.8 squared plus 20t plus 15. And there's actually a negative in this equation. Can't read about it. There's going to be a negative 1/2. So negative 1/2 times 9.8t squared, 9.8, so it'll give us negative 4.9. Negative 4, when we simplify this equation, we negative 4.9 t squared plus 20t plus t. Now we're ready to graph it and answer part B about how high the ball is after 3 seconds and find out when the ball will hit the ground. So let's just start from the beginning with this. So in our equation, we'll enter negative 4.9 instead of t, we'll enter x squared plus 20t. In this case, we'll use x plus 15. So the first thing we notice, we have an x-intercept. Looks at negative 0.647 comma 0. Let's label that. Comma 0. Oops, negative 0, not 9. And label it. There's our first x-intercept. We have a y-intercept at 0 comma 15, which makes sense because that's our initial height. And we'll label that point. We have a maximum value at, looks like 2.041, comma 35 points. .408. Oops, slightly off. Two point zero four one, 35.408. There's our max. And then we have our last zero, which is at 4.729 comma 0. And we'll label that one as well. So our next question asks, how high is the ball after 3 seconds? So we can figure that out by just plugging t into our original equation. Let's drag this up so we can just type it. So we'll type a negative 4.9 parentheses 3, close your parentheses and square. So we'll just type it, we're using parentheses to plug in the 3. 20 parentheses 3 to indicate multiplication plus 5. And after 3 seconds, it looks like we're at 20.9 feet. So let's answer part B. B after 3 seconds of ball is 20.9 meters high. And then we have to answer part C. When will the ball hit the ground? So that's the x-intercept. So we have two x-intercepts. We have negative 0.647 seconds and 4.729. The more interesting one is the positive one because we can't have negative time. So the ball hits the ground after 4.729 seconds. So we'll answer that question and we're done with this question. So after 4.729 seconds, the ball hits the ground. And we are done. Example 3. The Center for Disease Control studies trends in high school smoking. The percent of students in grades 9 through 12 who report smoking cigarettes on 20 of the 30 days preceding the administration of the National Youth Risk Behavior Survey, frequent cigarette use increased in the 1990s but decreased in 1999. Construct a scatter plot of these data. So we had the years after 1999, and then we had the percent of frequent cigarette use for Y. So we need to use Desmos to construct the scatter plot. So let's kill out all of our old data. So we want to add a table, and we'll just type in 1, 3, 5, 7, 9. Next we have 11, 13, and 15. 11, 13, 15. Now we type in our Y values. 12.4, 13.8, 16.1, 16.7, 16.8, 13.8, last 2 points, 9.7, and 9.7, and 9.4. We can't quite see it, so we have to magnifying glass, and we have a better picture. Now we want to come up with the quadratic regression model for these data. So our quadratic models are just in the form y1, you get the tilde, which is under AB, a x1 and the square plus b x1 plus c. And our equation is, we'll round to the nearest hundredth, y equals, we're going to just type in all the digits, negative 0.12065 x squared plus 1.634345 x plus 10.6981. And take there does look like it's offloaded because remember we are rounding. And when we use a graphic calculator, we have actual values. So there's our model. Let's write that down. For B, our model is y equals negative 0.12065 x squared plus 1.6345x plus 10.6981. Now, using the regression model, predict the cigarette use in 2006 and 2010. This interpolation or extrapolation? And you think the predictions are reasonable. So 2006, just for comparison, 2006 minus 1990. minus 1990 will give me 16. And we can see from our original data set, that's the highest we go is 15. And then 2010 minus 1990 would be 20. So these both will be extrapolation because we're outside our known values. So now let's plug in and see what we actually end up by. So plugging in 16 and 20. So say y equals negative 0.12065 parentheses 16 with the square button plus 1.63435 parentheses 16 plus 10.6981. So after 16 years, 5.9613 is the reasonable estimate. And let's see if we can copy this. So we don't have to type all that out here. Control C. And then hit Control V, type it in. Now we'll type in 20. So after 20 years, we have a negative answer, which doesn't seem reasonable because we're talking about percentages. The percentages can't be reasonable, can't be negative. So the 16 doesn't sounds kind of reasonable, but the 20 after 20 years, we're just and then negative percentages, which is not possible. So 20 years is not reasonable. So let's answer it 2006. We end up with 5.96%, which is okay. But in 2010, we end up with negative 4.87%. So this one's not reasonable. Hopefully this helps you understand how to work with quadratics and with quadratic regression.